Okay, I know you know that these two big triangles are kind of important from geometry. 30-60-90 and a 45-45-90. And I know that many of you have forgotten, and that's okay. It's normal to forget this. It's one of those things if you don't use it, you're going to lose it. And if you knew how to, I don't know, conjugate the verbs in Spanish and you don't do it for 2 or 3 years, you're going to forget. Okay, so you're going to forget this kind of thing. But it would be really handy if you had it fresh in your mind today. So I'm going to remind you. And I'm going to remind you how you can construct it, how you can build these things. Now, would you agree that the length of a side is related to how big the angle is that's across from it? You know what I mean? This 90-degree angle is across from the longest side. That's not a coincidence, right? And so if we've got a 60-degree angle here and a 30 there, then the side across from the 60 must be longer than the side that's across from the 30. Okay? So at least you should be able to think that through and know that if it's a 30-60-90, all the sides have to be equal. Not equal, sorry. All the sides have to be different. All right, so if this is my 30-60-90 triangle, I'm going to remind you that see how it's 30 and 60? Doesn't it seem like one of them is double the other one? And there is one side in this that's double another side in this, but it's not what you'd think. Do you remember which ones are double each other? What do you think? The hypotenuse is twice the size of the smallest side. If I don't know how long it is, doesn't it seem reasonable to pick x? So I'm going to say x and 2x. And does anybody remember what this one is? Yes? Yes. Now, if you didn't remember that, you could derive it by using, if you know any two sides in a right triangle, can't you find them with Pythagorean? You see what I'm saying? Pythagorean comes in really handy because you're using right triangles all the time because they're the only kind that work with a sine, cosine, tangent, right? So you're always stuck in right triangles, so that right triangle big formula is going to be handy. So I could say that x squared plus I don't know squared, that's a 2 squared. Stay focused, please. Thank you. Is equal to 2x squared, and that would be x squared plus I don't know what squared is equal to 4x squared. Remember, you got to square both parts. And then subtract it, and then it would be I don't know what squared, should have used a variable, is equal to 3x squared. And then I take square root of both sides, and I'd say I don't know what is equal to square root of that, which would be square root of x squared is x, and the square root of 3. And that would be a lot easier if you just remembered it. But now it'll hopefully be fresh in your mind. Okay, so you got your sides that are double each other, and then this one's got that crazy square root of 3 added in. Okay? All right, the 45-45-90. Well, that one again, know it's important. And what do you know about the 45-45? That's telling you something about those sides. What do you think it's telling you? They're equal. So if I don't know what they are, so what should I put? X and X. And again, this time, don't say it. Think. Don't say the answer. Derive it in your head if you haven't already. Use the x squared plus. Who's got it? Raise your hand if you've got it. All right, quite a few people do. Claire. Excellent. And if you hadn't been able to figure that one out in your head, on paper, hopefully, you could have gone x squared plus x squared has got to be I don't know what squared. Making a question mark out of it. And then it would be 2x squared is equal to something squared. And then I could say divide by 2. And so it ends up being x squared is equal to, anyway, long story short, she's got it right. All right. If you remember these little triangles, they will really help you a lot, and I call them helper triangles. It reminds me of Helper Monkey from Homer Simpson. Homer Simpson one time got jealous of the people who had like assisting animals, you know, like, and so he bought himself a helper monkey to like get the remote for him and that kind of stuff. So anyway, this one is a 45-45, and it's got all the right relationship, but what's kind of missing? What would normally be here? I thought there was supposed to be something there. But x is 1. If it's supposed to be an x there and x is 1, then what really should be there? A 1, but 1 times anything is still that same thing, right? So it's okay. This has got the right relationship. But if you memorize it this way, it's going to be a little confusing later because you're going to forget that there's really whatever this is has got to go there. So in other words, if I redraw this and I say 2 and the square root of 2, would that be right? No. It would be 2 times the square root of 2. See what I'm saying? All right, so if you're going to memorize this one, probably best to use that variable thing. I kind of like that way to do it, where you say this is x, and this is x, and this is x times the square root of 2. All right. So here's a 45, 45, 90, and it's kind of cluttered here. I'm going to get rid of these guys for now. So if I want to figure out how big x is, and I know this and this, if I get a little confused, draw yourself a helper triangle. X, 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 and square root of 2. And then I can just look at it and say, oh yeah, these are supposed to be the same. So these are supposed to be the same. So what's that got to be? And then I can look at this and say, okay, I got x, and then I get x root 2. Seems like it should be what over here? 6 root 2. Good. All right. And now you might have dissed my helper triangle because you're like, oh, I could have done that in my head. All right. How about now? If I make that a 10, all of a sudden you might like your little helper triangle because it's not so easy anymore. All right. Here's how you can use helper triangle. He can either be really simple like this. That goes with that, right? And so I can set 10 equal to x times the square root of 2, and I solve it for x, and x would have to be 10 over the square root of 2. Do you get that? So that means if this is 10, then x, which goes over here, is 10 over the square root of 2. The only problem is you're not allowed to write 10 over the square root of 2. You know why? Because you're not supposed to have a square root in the denominator. Do you remember that? So if I have 10 over square root of 2, this is called rationalizing the denominator, crash course. You're supposed to not have square roots in the bottom. So I can multiply anything by 1, right? And it won't change it. So if I multiply it by square root of 2 over square root of 2, isn't that the same thing as 1? And so why would I do that? Because then the square root of 2 times the square root of 2 makes a square root of 4, which is really 2. And the top is 10 times the square root of 2. So there's my final answer. So just don't leave square roots on the bottom. All right, I want you to try one of those right now. Say you had this one, and this is 13. Figure out for me what those two are. If this is a 45, 45, 90. I'll pause while you do that. Okay, I probably would have drawn my helper triangle, and it's a 45, 45, 90 helper triangle. And so this is x, and this is x, and this is x root 2. Did I draw my helper triangle right? Okay. And then here, I'm going to show you a different way you could use. You could say, if I want this, I don't know what it is, I'm going to call it n. And it's going to be the same as this other one, right? So I can figure out that 13 goes with this. 13 goes with x over the square root of 2, like n goes with x. That's another way you could do it. And then you cross multiply and you solve. 13x equals n times x times square root of 2. Then I divide both sides by x's and they cancel, and I'll have 13 equals n times square root of 2. And then I'll have n equals 13 over the square root of 2. Am I supposed to leave it like that? No. 13 over square root of 2 simplifies down to multiply both sides, top and bottom, by the square root of 2, so I'll end up with 13 root 2 over 4. Raise your hand if you had that one right. Did I screw something up? Oh, it's over 2. Sorry, it's over 2, not 4. Sorry. Raise your hand if you had that one right. Okay, good. Sorry about that. All right. 30, 60, 90, same idea. Yes, there are multiple ways to do it. I don't want to go over all of them. All right.